Hello and welcome everybody. This is Noah, and in this video we are going to look at how to solve absolute value equations graphically. Alright, so we're going to do this by hand. The instructions say solve the following absolute value equations graphically. Draw the graphs by hand without technology. So we're going to begin, in order to solve this equation, by setting f of x equal to the absolute value of x minus 3, and we will set g of x equal to 5. I want to get a coordinate plane set up. So I know with absolute value functions I never have negative outputs, so I can draw a vertical line and then draw a horizontal line here. Oops. Another straight line shape. Alright. There we go. And I'll just label my x and y axes here. So I'll start by just graphing g of x. That's the easy thing. That's at 5. So I'll just go up 1, 2, 3, 4, 5 and draw a horizontal line in blue. So y equals 5. That's our g of x function. And now we want to look at f of x. Let's actually change this color to red. So I'm going to start by looking at just y equals x minus 3. And if I set and say, when does this equal 0? If x minus 3 equals 0, that's when x equals 3. So I'm going to go to where I have a 3. Let's get a scale on here. Let's say it's 6, 3. Every grid line is just going to be with 1 here in both directions. All right, so at x equals 3, that's where this is going to bottom out at 0. The v-shapes are always upward facing, never left or right. And I have from this that the slope should be 1. So from this point at 3, 0, I'll draw a slope of 1 up and to the right, up 1 over 1, up 1 over 1, crossing all of my grid lines at nice integer values. And then I know also that if I did the negative of this, y equals negative parentheses x minus 3, this equals negative x plus 3, we could go and draw the point 0, 3 for the y-intercept and have a slope of negative 1. And if I look at the right line of this absolute value function and the left line, they have the same slope, but one's positive and one is negative, and they will always bottom out at the x-axis here. All right, so let's go ahead and find these intersection points. We have the point, looks like 8, 5, and then the point negative 2, 5. I'll label my graphs. This is y equals the absolute value of x minus 3. So from this, I can see that the absolute value of x minus 3 is going to equal 5. The outputs of that when x equals negative 2 and x equals 8. So we can say that the solution set is the set containing negative 2 and 8. That's it. That's all we got to do. We're going to do one more example of this. With something just a little bit more complicated of numbers, but the same idea. We want to solve the absolute value equation. The absolute value of 2x minus 1 all divided by 3, close absolute value, equals 3. So once again, we'll set the absolute value function to f of x. F of x equals the absolute value of the fraction 2x minus 1 on top, 3 on the bottom. Those are absolute value. And g of x, so the f of x I'm doing in red, g of x I'll do in blue. G of x equals 3. And I'm going to get some axes drawn here. So I know with absolute values, once again, that I never have negative values. So just draw a horizontal line towards the bottom of my graphing area. And I'm not really sure left or right where I'm going to go, so I'll put my vertical line kind of in the middle. Plenty of room. I have x on my horizontal axis, y on my vertical axis. And let's start with just the easy thing, g of x equals 3. That's a horizontal line at y equals 3. Put a scale on my y-axis. 6 up there. That's fine. And let's just go by 1s in both directions. So in the x-axis, I'll label 4 and 8, and -4 and -8. All right. So now I want to graph my absolute value function. I have y equals, and let's just get rid of the absolute values and look at 2x minus 1 over all over 3. We're going to break this up as 2x over 3 minus 1 over 3 by breaking it into two separate fractions. Note if we brought that back together, they have a common denominator, so we just subtract the tops. I can also pull the x in front, so this is 2/3 times x minus 1/3. So I can see that my slope is 2/3 and my b value is -1/3. So I'm going to go to, I want to find the x-intercept here. So I'm going to set the whole thing 2x minus 1 all over 3 equal to 0. Multiply the 3 over to get 2x minus 1 equals 0. And I'll add 1 and divide by 2 to get x equals 1/2. That actually tells me I want to change my x scale. Let's make 1/2 for each grid line. So we'll say that this is 2 and then 4. And -2 and -4. So my x-intercept here is going to be at 1/2, comma 0. And from here, I should have a positive slope of 2/3 moving off to the right. So I'll go up 2 over 3, up 2 over 3, up 2 over 3 again. And then I can take a negative slope of the same thing. Go up 2, back 3, up 2, back 3, up 2, back 3, and draw our line. So keep in mind as we're drawing these absolute value functions, it's just kind of nice to find that x-intercept first, and then we find the slope for it, and we can just draw our line off of the x-intercept using that slope, positive and negative. The v is always, always upward facing. All right, so now we want our intersections. It looks like this is, these grid lines are 1/2, so this looks like 2.75, comma 3, and the one on the left here, this looks like -1.75, comma 3, because it's halfway between negative, like, here's -1, -1.5, so it's halfway between -1.5 and -2, so that's how I'm seeing it's -1.75. All right, so from this we can see that the x values of these intersections are the solutions to the equation. So I will say that the solution set is the set containing -1.75 and 2.75. Last couple of things to clean this up. I want to label my y equals f of x for the red line, just so I can see the red line is the function f, the absolute value function, and the blue line is y equals 3, the horizontal line. All right, that is it for this video. Go ahead and pull up the Now You Try problem, give those a shot, and then you can watch the next video where I will walk through those solutions. Thank you so much, and I will see you in the next one.